Hi guys, so in this video I'm going to show you two ways that we can write a function that takes in a string and checks if it is a palindrome, i.e. that it reads the same when it is reversed. So if we pass in Dan, then Dan doesn't read the same backwards because we reverse this, it says nad. Whoops. Nad. And then if we say we pass in noon, then noon backwards is still noon, which is true, so this should return true. But what about if we have noon and then we reverse it to say noon? Well, this should be true because we're just going to ignore casing, okay, whether it's capital or lowercase. Okay, so first we're going to write a function called isPal. So is it a palindrome? We're going to pass in a string, and what we're going to do first is we're going to reverse this string. So for this function we're going to reverse the string and check if it's equal to the input string that we put in. So we're going to say let reversed string, rev string, equal to string dot split. So that's just going to put it into an array of characters. So let's return so you can see what is going on for each stage. Okay, so this is just split the string up and put each character as an item into an array. And then what we can do is we can reverse this array using the reverse array method. So there we go. So now it says nad, and then we can join it back up together using the join method, pass in an empty string, and we've reversed the string. So now what we can do is we can lowercase this, so we're going to ignore casing using the lowercase method, and we're going to check if it is equal to the string that we inputted, which is Dan, and we're going to lowercase that as well. And as you can see, it returns false because Dan reversed is nad, and it doesn't equal Dan. Okay, but what if we pass in noon? We get true. And also if we pass in with a capital N, we get true as well. Okay, because noon reads the same backwards as it does forwards. So this has got what's the sort of performance of this? Well, split is looping over every item in this string. Reverse is also looping over every item in this string. So is join. So that's like 1, 2, 3 times the length of the string operations, so 3n. And then lowercase is doing the same thing, and lowercase again. So it's about 5n, right? And n is the length of the string. So if the string is 4 characters long, it's going to have roughly 20 operations. Okay? For string of length 5. Okay? That boils down to a big O of n, because we look at the big picture with big O, and we can just ignore the 5 because as the string length approaches infinity, 5 times infinity, it's just still infinity, a very large number. Okay, so we can improve on this a little bit by, again, if you watched the last video, we used pointers, and we can improve on this using pointers again. So pointers are a pretty good way of improving performance of an algorithm. So pointers, I'll just get rid of that. Okay, so first of all, I'm going to lowercase the string. So I'm going to say LC string for lowercase string. I'm going to put that equal to the input string dot to lowercase. Okay. Then what we want to do is define a couple of pointers. So we're going to say left is going to be equal to 0. So it's going to point at the very first index in the input string. So I'll just write console.log it out with a string in there. So let's just put Danny in there first of all. So left is going to point at index 0, which is going to be this capital D. Okay, and then the right pointer we're going to have pointing at this lowercase string dot length minus 1. And that's just going to be the very last item in the string, which is a y. Okay? Now we can write a while loop and say while the left pointer is less than the right pointer, we can do some stuff. So first of all, we're just going to check to see if the left hand side, which is D, is equal to the right hand side, which is Y. And if it isn't, then it can't be a palindrome, can it? Because if we reverse this, it's going to be YNNAD, which is not Danny. So we can just do a check to say if the lowercase string, the left hand side, and if it doesn't equal to the lowercase string right hand side, we can just return false, because it can't be a palindrome. So we just get out of this function and return false. So now if we log that, we can see we got false. And this is good now. This is a massive improvement on this first algorithm, because in this first algorithm it doesn't matter what the characters in the string are, it's still going to loop over every single item in the string, whereas here we only have to do one check. We only have to do one loop. We just check, is D equal to Y? Well, no it isn't, so we're just going to get out of this thing and return false, right? We're not going to even bother checking the rest because it can't be a palindrome. Okay, so then let's pass in something that is a palindrome now. So if we pass in noon, we need to increase the left pointer and decrease the right pointer, so these things are moving towards each other. So the first run through, left is equal to n, and the right is equal to n as well, and n is equal to n, so we're going to ignore this and we're going to go down to here, increase the left by 1 and the right by 1. So now the left is going to be equal to the second O, and the right is going to be equal to the third O, okay, because they're moving towards each other. And O is equal to O, so we're going to ignore this, come down here again, the left is going to increase and is going to become the third O, the right is going to decrease again and become the second O, and now the left is now greater than the right, okay, because the left is now pointing at 0, 1, 2, the second index, whereas the right is pointing at 0, 1, the 1 index, okay, so we're done here, we've checked all the characters. There was no problems, we didn't have to return false at any time, so then therefore it must be a palindrome and we can return true. Okay, and as you can see here, it's returned true. So this is definitely a better way, more performant way than the first way. The reason for that is because, again, we're only looping over. At worst case, right, at the very worst case, if it is a palindrome, we have to loop halfway through the lowercase string, okay? So even at the worst case, it's still better than this, because this is looping through every single character in the string, whereas this is only looping through half. At the very best case, again, if we pass in Dan, at the very best case, it only has to do one check. It just checks if D is equal to N. No, it isn't. Let's get out of here. So if you've got 1,000, a string with 1,000 characters, etc., 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 this first one is going to have to loop over every one, whereas this one, it just checks if it is the last character equal to the last character, and if it isn't, say here, it just gets out. It doesn't have to loop anymore. So at best case, this is way better than the first one, especially for longer strings. Okay, but it still has a big O of n, because it uses this to lowercase method, which has to loop over every one of the strings. But here, at best case, this is just constant time, really. It's just one operation, one loop. At worst case, it is half n, so half the length of the string in loops, and half n, we would just say that as a big O of n, okay, because it just roughly boils down to big O of n. So whilst both of these are big O's of n, this one could be a lot more performant, especially for larger strings. And again, if you're in a job interview, it's definitely worth, probably worth writing out this one and say that this is a good performant way of doing it, or more performant way than, say, the brute force way of looping over everything. But of course this is a much easier to understand algorithm, so if the strings are pretty small, then this one is absolutely fine. There really is no reason to write all this out. Okay, but for very large strings this is worth considering. So that's about it for this video. Hopefully that wasn't too confusing. Let me know in the comments what you think. Thanks for watching, and I'll see you in the next one.